Please, for the sake of Wednesday, pay attention. Make sure you ask any questions that you got if I'm trying to be as clear as I can, okay? Question number one. Who feels like they got an E? Hit me. What you got?
The answer?
Just talk to me about what you got.
Well, first of all, I drew the graph thing.
Normal curve?
Yeah.
Okay.
And because 22 is the mean, I put that in the middle. And
Just like that?
Yeah.
That's it?
No. Because the standard deviation was 4, I went 4 both ways. So like the right would then be 26, and then to the left it would be 18, just to kind of like map it out.
Gotcha.
And then from there, I plugged that into my calculator.
Okay.
And I got 22.26.
That's what you got right there, just like that? Anybody else? Talk to me.
So I also drew the normal distribution.
Yep.
And then in the middle, I wrote, is it mu?
Yep.
Equals 22.
Okay.
And for the standard deviation, what's that word?
Sigma.
Sigma equals 4. And then I went to 22 and drew a line, or not 22, 25.
25.
25 would be a drew line, and then shaded everything after that.
Okay.
And then I wrote T is greater than or equal to 25. And I put that in my calculator.
Anybody else got something? Let's hit the rubric and see how both of them would have done and how you would have done. Here. Step one. Step one, state the normal distribution value. This is the perfect answer. Perfect answer, right? So we'll go through the rubric in a second. Model solution. State the distribution of values of interest. The distribution of scores follows a normal distribution. Mean at 22, standard deviation 4. We want to find the scores that are at least 25. Perform the calculations, show your work. The standardized score is 0.75 because that's the z-score from table A. The proportion of z-scores above 0.75 is the 0.2266, or using technology, the command normal CDF lower 25, upper 1000, mu 22, standard deviation 4 gives an area of 226. Answer the question, the proportion of students who scored at least 25 points is at least 0.23. Okay, here's the scoring. E, if you got these three things, if you get an E, indicates the use of a normal distribution and clearly indicates the parameter values. Mean, standard deviation, normal. I think we're okay even though he didn't label mu equals and standard deviation equals. I think it's intended because we had 22 right in the middle and we want one to the left and one to the left and one to the right. I think we're okay. We're really okay with mu equals and standard deviation equals, okay? But they go on to say that using a z-score is sufficient. I don't figure many of you did that, but however knows that. Uses the correct boundary value, 25, to the right of 25. I'm not sure we're hitting that on some of those. And then reports the correct normal proportion consistent with components 1 and 2, meaning that if you messed up 1 and you messed up 2, as long as your proportion fits that, you'll get credit for number 3. Okay? Partially correct if you only hit 2 of those. Now here's the notes. Following examples of clarity identified in parameters. Writes mu equals 22, standard deviation equals 4. Explicitly labels the mean and the standard deviation in a normal CDF calculator statement. Sketches a normal curve, labels 22 as the mean, and labels the 2 additional consecutive values separated by 4. And I think that's where we got covered. He wasn't 2 additional to the right, but it was 1 to the right and 1 to the left. I think we're okay with that. Okay? Yes, sir.
So would I have done an E?
I think so. I think. Let's look at this student's answer. Okay? Let's look at this student's answer. This student has a nice picture over here. They got the 22, they got the 26, they got the 18, and they put the 25 to the right. I think that might where you might be missing at. is shading it to the right and talking about greater than 25. They got normal CDF with lower 25, upper 1,000, mean 22, standard deviation 4 equals 0.2266. Okay? This is scored as an E. It's showing a normal distribution, identifies the parameters in a normal CDF command. The boundary levels were identified in the picture and in the normal CDF command. The corresponding proportion was calculated correctly. So part A was an E. Check out this student. Z equals 25 minus 22 over 4, 0.75, and then they found 0.7734. So this answer here actually says uses the correct Z-score calculation, earning credit for both components 1 and components 2, because Z is telling you that you have a normal distribution and we're using the mean and standard deviation. We converted it to 0.75. Okay? However, the response identified a proportion of students who scored at most 25 instead of proportion who scored at least 25. Furthermore, the response incorrectly calculated 0.75 equals 0.7734 because only 2 of the 3 components were correct. That was scored a P. Yep. I don't dock any points.
Are you going to?
You earn points.
Okay, will I not earn points if I draw a graph incorrectly, even if the question, like if I forget like the unit scale at the bottom, but I get the right answer, I just sketch it out for myself. Like,
Is somewhere on there telling you what the mean and what the standard deviation is?
even though it doesn't ask for you to draw it,
You got to have it.
you gotta have it.
Okay, now you don't have to draw it, but you got to have labels somewhere telling me what the mean and what the standard deviation is. Yep. Yeah. Yep. Everybody good? Question 2. Question 2. I'll just do this. Who feels good about question 2? Go ahead, Isabel. What do you?
So I did inverse
Okay.
calculator, and I put in the area as 0.31, and I put in the mean as 22, standard deviation is 4, and then I put in left. And I got 20.22.
Anybody else? You're okay with this as long as you label. You got to label. If you don't label, 0. If you don't label, you're going to get 0 on that. Okay? Did I write it wrong?
Yeah.
20.02?
Yeah, because it's the score of the test.
Oh, okay. That's the X value, right?
Yeah.
I'm sorry. I heard you say that. I was turning it to a percent. Okay. So they're going to do almost the exact same thing here, guys, with their rubric. Okay. They're going to give you 3 things that we got to hit. Okay. 3 things. Again, here's the model solution. Notice my model solution, guy. I recommend drawing it, labeling, shading. Okay. Doing those things more than likely are going to get you a P without doing anything else. And in this particular case, it did, because you hit number 1 and you hit number 2. Okay. Here's the E. Indicates use of a normal distribution, clearly identifies the correct parameters, using Z-score is sufficient. Does the correct area value or uses, and then reports the area, the correct percentile consistent with components 1 and 2. Partially correct if you only hit 2 or 3 of those. Again, writes mu equals 22, sigma equals 4. Explicitly labels the mean and standard deviation in an inverse norm calculator statement. Okay? If you write the calculator statement, you can, but you got to label what those values are. Lower bound, upper bound, mean, standard deviation. Okay, and that's why I think shading it does a much better job. Sketches a normal curve, labels 22, consistent with 4, and then correct identification parameters in part A. Look at this student's answer here. Normal curve, 22, 26, 18, 31. Inverse norm area, 0.31. Mean, 22. Standard deviation, 4, 20. Yay? E. E. The response indicates a normal distribution. Identified the parameters. The correct area was identified in the picture and in the normal CDF. And the corresponding percentile was calculated correctly. So that was scored an E. Z, X minus 22, 4, got 20 for X. That actually was an E. In part B, the response used the correct Z-score calculation, earning credits for both components 1 and components 2, calculated the correct percentile. Part B was actually scored an E. Okay? Turning things to Z-scores is sufficient a lot of times. All right, here's C. We're going to do this one because I know you guys struggled a little bit. Let me just do it for you because this doesn't do the greatest job of, again, I hit the wrong thing. Okay. So here's what they wanted, right? They wanted the mean to be 80 and the standard deviation to be 10. Is that right? 80 and 10? And what is it currently? 22 and 4? Okay, so then they say new score equals A plus B old. New score. I have dyslexia, leave me alone. And that's A plus B. That looks like at bold. Okay, y'all good? All right, standard deviation. Addition and subtraction do not affect it. Addition and subtraction do not affect it. So if addition and subtraction do not affect it, I can plug 4 into old. And I want the new standard deviation to be 10. And so I'll divide both sides by 4, and I will get B to be 2.5. Okay? Yep.
If I just wrote 10 divided by 4 equals B and then put B equals 2.
You're good. You'll see the rubric in a second. Okay. Now I want the mean, and mean is affected by both addition and the division. So I'm going to put that 2.5 in for B because I already have that. So the new score I want to be 80. I want the new score to be 80. A is what I don't know. B I know is 2.5 already. And the old mean was 22. And so that I'll solve for A because both addition and the multiplication are affected by A. I don't think it's possible to find the mean first. I think you got to find the standard deviation in order to be able to figure out what B is. Okay, a different way of looking at it than you guys probably saw in your homework. Okay, now let's go back and let's hit my rubric and see. Okay. So, because adding a constant does not affect the measure of spread, then we'll take that 10 divided by the 4. We'll get B is 2.5. Here is the old score. There's where we get A is 25. Okay? Here's how it's scored in E. Essentially correct that the response calculates both correctly and shows appropriate work. In other words, you got something down there besides a naked answer, right? You got something that shows you how you got those two values. Partially correct if you only got one of those two values correctly and shows work, or you got them both correct but you didn't show anything. Okay, so that's how you can get a P. And then I otherwise. Note, if the standard deviation is calculated incorrectly, and then the mean is calculated correctly because of the incorrect standard deviation, then you will get a P. Okay? Because if you miss that, you've got to miss this other one. But they don't want to double ding you. So if you missed this, but you used it over here, you'll get a P here as long as you got it right, consistent with yours. Here's what this person did. They got 180 plus 10 old score. That for the The A is 80 and the B is 10. By doing this, you bring the average up to a mean of 80. I missed it. Missed both. Didn't hit either one of them, so it's an I immediately. If you missed them both, it's an I. Pretty easy to grade. This one, they got a 2.5. They got some work, so you're good there. Then they got 58, that's wrong. So they hit this one, they missed this one, they got a P. That one's like one of the easiest ones in the world to grade. You look to see if it's right. If it's right, you look to see if they got work. You look to see if it's right. If it's right, you look to see if they got work. Wrong, wrong, I. Right, wrong, I. A P. Right, wrong, no work, I. Okay. This last question, I want to hear from you guys on this one. I want to hear from you guys on this one. Talk to me. Who feels good? Who feels good? Who feels good? Come on. Yeah? Come on. Come on. I think it's an easy question, I think. Go ahead.
I just said no because this is so close to the maximum score, meaning that it would be symmetrical on either side with lows and high scores, so a normal distribution wouldn't fit that shape.
I think we're at a P. That's close. It's debatable. Hit me.
I said because like, if you were to add one standard deviation to 9.2, that's not 68% of like your data, so it doesn't follow the numerical rule, meaning that it's not normal distribution.
We're still, I think we're close. We're close. I think we missed something on that one, but I think you've put hers and hers together, I think is what they're looking for.
So comparable in shape.
Something, go ahead, keep going. Talk to me.
I said no because the maximum is too close to the mean because the z-score is only like less than 1.
Still missing something. Z-score of 1 doesn't tell me that, a z-score of 1 still doesn't tell me that it's not normal. Y'all see, you hear what I'm saying? It still doesn't tell me that it's not normal. It tells me that you're only one standard deviation away. If it's normally distributed, the max better be at least what? 2 or 3 standard deviations away, at least, right? We're less than 1. So that's kind of their linkage for all that. You got to talk about a normal distribution and what it would look like. Then you got to talk about this distribution and what it does look like and how it doesn't look like that one. Okay, so let me hit the rubric for you, and hopefully this will clear it up even a little bit more. We'll see. Okay. Part D, essentially correct. First of all, you got to say no. That's the third part. You got to have a no in there. That's where I go back to ATQ, answer the question, right? No. So I got to see a no in there. States a relevant characteristic of a normal distribution. A normal characteristic of a normal distribution. I think that's what we did here, and I think that's what we missed a little bit here. I'm not too sure we hit it quite right here. Yeah, it can be, that can be uniform or double by, right? Symmetry really doesn't set that. That's why I say it was close. I think we're just missing a little bit. Okay. And then uses 3 summary statistics. You use the mean, you use the standard deviation, and use that max. I do think all 3 of you guys did do that, because I think that's what's somewhat telling you. You got a mean, you got a standard deviation, you got a max. 2 of you said that the max is too close to the mean. Too close doesn't necessarily mean it's not. I mean, you could be too close. If the standard deviation is 0.005, you could still be really close to it and be a normal distribution. Y'all see what I mean, right? I mean, you can be really close to it. If the standard deviation is 0.006, you're going to be really close to it. So I don't think that's really telling me that it's not normal. Kind of makes sense. Y'all kind of just follow. Sometimes you have to read it like, well, who would do that? Well, you just got to tell me what you know. Yeah, I understand what you mean by it's too close, but because it's not too close, that doesn't make it normal. It's too close for the standard deviation to be that. That kind of linking all that together, okay? It does say this down here in some notes, okay? A response calculates appropriately that 35% should be above 10 with a normal distribution with a mean and standard deviation. It states that 0% is above 10 and therefore concludes that a normal distribution will be inappropriate. That's enough because you linked both of them. You told me about the normal and you told me about this distribution and you told me how they don't look, it's just that they can't work. A response that states that it would be inappropriate to use a normal distribution because the maximum score is 10 is less than 1 standard deviation above the mean should be scored a P because it doesn't state a relevant characteristic of a normal distribution, i.e. a normal distribution, the max should be 2 or 3 standard deviations away. A response that states it would be inappropriate to use a normal distribution because 68% of the values should be within 1 standard deviation of the mean, or 95 should be within 2, should be scored a P again because the response doesn't show how the actual distribution doesn't have that characteristic. So you had to basically talk about what a normal distribution does. You had to talk about what that distribution does and how they're different. Everybody okay with that? I want to talk to you about 2 more things just to make sure you guys understand. Okay. I don't know what the shape of distribution is. I don't know what the shape is. It could be anything in the world. Feel good? Anything. I don't know what it is. Can you find the z-score? Can you find the z-score if you don't know what the shape is? What's the definition of a z-score? The number of standard deviations the point or the value is away from the mean. Does it say it has to be a normal distribution? No. So you can find the z-score anytime, no matter what the shape is. You can't turn that z-score into a probability unless you know it's normally distributed or it's uniform distributed, because we can use a uniform distribution because it's length times width. Okay with that? So you can find the z-score for anything. That's something that a lot of students mess up somehow, some way, and it's probably the way it's delivered to you, I'm sure, because no way that nobody can mess that up without it's a bad delivery. So I want to make sure that that's delivered correctly. You can find the z-score anytime because the z-score tells you how many standard deviations away you are. If you're 1 away on the bottom side and you're 1 away on the top side, and that's 68% of the data, chances are really good we're looking like a normal distribution. But if we don't know any of that stuff, we can't turn it into percentages. Okay? Y'all good with that? So those are the 2 things I want to make sure you knew. You can find the z-score for anything. You just cannot turn it into a probability unless you know it's normally distributed or uniform. Okay? So make sure you know that. Also, let me share with you this. This happens a lot, and I answered the same question like 4 times today. So I want to make sure that you guys understand the link between this, okay? So, males, I'm making this up. Average height of male is 71 inches with a standard deviation of 2 inches. Okay with that? So, and it's normally distributed. So we got a normal distribution with a mean of 71 and a standard deviation of 2, okay? And so I can turn off percentages, I can do whatever I want, okay? All right. Now, this is a common question that's going to be asked several times on homeworks, your reviews, and or the test. They don't tell me the mean, or they don't tell me the standard deviation, one of the 2. They don't tell me either one. They have to tell you something else. They have to. They'll say something like, it is known that 35% of all males are taller than 73 inches. It is known that 35% of all males are taller than 73 inches. Okay? So I know that from here. And I have to know that 73 is on this side because that's 35%. If that was like 65%, it would be over here. Because right here is 50%. You okay with that? And then it's going to ask, what is the mean? Well, that's where you guys got to associate this distribution with a normal distribution, a standard normal distribution. And what I mean by a standard normal distribution is, in a standard normal distribution, they don't have to give me 3 things. They only have to give me 1 thing because I already know that that's 0 and that's 1. And if I know that 35% are taller than 73, I can say that 35% are taller than whatever that value is because I can do inverse norm of 0.35 right with that mean and that standard deviation, and I can get that score. Are y'all with me on that? I'm kind of doing this without actually doing it, but I'm doing it. So that score right there tells me that 73 is that many standard deviations away from the mean. Because if I do inverse norm of 0.35 with 0, 1, that gives me a z-score. Well, that z-score is the same thing as 73 and that 35 and that 73. So if I know how many standard deviations that 73 is away from the mean, I know that z is equal to x minus the mu over the standard deviation. So I now know this z-score for that 73, and I know that x is 73. I don't know what mu is, but I know the standard deviation is 2, and I don't know what that is. Let's just say it's 3. I don't know. Okay, that's probably way off, but good. So we just cross multiply, move that 73 to the other side, and now you know what mu is. And that works with finding the mean, and that works with finding the standard deviation. Okay with all that stuff? But they got to give you enough information to basically convert it to a z-score for you to tell me how many standard deviations that value is away. And once you know how many standard deviations that value is away, I can use the z-score formula to calculate either the mean or the standard deviation. Okay? And just make sure you guys know algebraically, I know it's been a while for some of you. If I'm looking for the standard deviation, let's say the z-score is 2.1, and let's say that that's 71, and let's say that this is 76. That has to be the other way around. This has to be 62. Okay? I just switched these two. Just switch them. You're multiplying both sides by the variable and dividing both sides by 2.1. But if you just switch those two, then that finds it really easy. Okay? All right, your task today. One of two things, I guess, or three. Finish up any homeworks you need to make sure you finish up. You have homework. You have a review posted on AP Classroom. I'm sorry. Achieve, thank you. 10 questions, right? I did post some videos on AP Classroom. Do be aware that AP Classroom has Unit 1, which is our chapters 1 and 2. Okay? And then I got you 20 multiple choice questions down here. They are amazing because they're not the easiest problems in the world. Okay? In fact, if you do all those and understand them, I'm really sure you'll get a couple right on the test. At least a couple. I mean, you can get them all wrong, but if you get all those right and you understand them, you got to get